Hi, this particular exercise is to show you how to draw free body diagrams for a variety of systems in a proper manner. I'm sure with our class yesterday, you found that actually knowing just the joints is actually not enough for you to be able to draw free body diagrams. It turns out to be surprisingly hard, no? So what I'm going to try and do is show you some examples so that you can see what the difficulties are and how to do it. Okay. So first example is this wheel which we did in class. I'm going to do that again. So what I want to do is draw a free body diagram of this wheel. So I'm going to cut this out. I'm going to cut this out. Let's see. So first step, draw the circle with the hole cut out. Okay, that's step one. Forget about all the stuff that's inside. Now let us go and look at each place where I have cut. So let us call this point A, point B, point C. Okay, so let's look at point A. It's way up here, and I look at it. When I look at any particular point, I ignore everything else. I ignore rest of the figure. I don't even care about it. So I'm going to look at just this point and I say, what kind of connection is there? Well, is it obvious to you that it's a cable connection? If it's a cable, I'm going to use this. There's the cable connection. So I'm going to say the force here is T1. I don't care how much it is. We will let Newton tell us later. Okay. Then look at point B, which is here, and I'm going to have cut it there. So the force there is T2. I don't even care about the rest. Then at point C is very interesting because this point is actually a axle and it is spins. So the constraint force disallows dislocation of the shoulder. That is, it does not allow either this motion or this motion, but allows spinning. So I'm going to go up here and I'm going to say, okay, this force is necessary to disallow X motion. This force is necessary to disallow Y motion. T1, T2. So it takes care of all of this. Then the last one is the external torque. Can you see this arrow here? I'm going to draw that arrow there. That's the external torque. And many of you would be interested in gravity and so on. If you think that the wheel is very heavy compared to all the other forces, you want to put W wheel. That's my free body diagram. Okay. Let's look at example number 2. This one, I want to draw the free body diagram of this bar. So this creates lots of confusion. So for a lot of people, so I'm going to cut the string here. I'm going to go across. I'm going to remove this joint here. I'm going to go across, remove that joint there, go across, cut this string there. So here is the figure. I don't care what's inside. At point A, there's a pin joint. I don't care about the rest. I will blindly put FAX, FAY, FAX. Then at point F, there's nothing. At point C, there's another pin joint. In later, as we get more experienced, we will start using more detailed and cleverer analysis. Here, we are not going to be clever. We are just going to be systematic. So if it's a pin joint, I'm going to have two forces, FCY, FCX. Notice I don't even care about whether these things are balanced, unbalanced, nothing. I'm just saying blindly pin joint, pin joint, pin joint, that's all. Okay. Then I cut the cable here. So there's a cable force T1. And I cut the cable here, so there's a cable force T2. And that's the end of it. And I'm going to draw my x-axis here. So x direction is like that, y direction is like that. That's it. That's all. Notice I don't care about balance. I don't care about forces not on the outline. What do I mean? I don't care about this one, because as far as the bar goes, the only thing it says is something is pulling on it. It doesn't know it's actually a big box. And I told you that the forces that we encounter are actually sense of touch, not sense of sight. So it doesn't actually see the other forces, it's just there. Okay. So next one, this is an interesting one. So let's see. I'm going to draw for the bar ACB. So I'm going to draw the bar ACB. So there is the bar. This is B. This is C. This is D. Okay, so let's see the joints which we already know. What kind of joint is at C? It's a pin joint. So I'm going to put blindly FCY, FCX. What's the kind of joint at B? Can you see that there's a cable here? So this is FB cable. Those are the joints which we know, right? Now look at the drum. The drum is touching this point and it's like an unpowered wheel. So there is no friction, there is no nothing. So the drum force the kind of joint is called a roller joint or rocker joint. And just to get you an idea, rock and roll are the same in this. Okay, so what happens is this joint is also a rocker. This is also a rocker. For a rocker joint, it's very interesting. It's very simple. I'm just going to draw a force like that. F drum. And then F ground. You see that? Stare at it a little bit. So these two joints are the same as this pin slider. Okay, because how did I know that? You look at that joint. What can it do? It allows the drum to rotate, so there can be no torque. It allows the drum to slide, so there can be no force along that direction. It does not allow the drum to do this, that's why there is a force. That makes sense to you? So this joint by itself allows this. Of course, the total drum depends, what the actual drum does depends upon what the other joints are. But each joint knows only its task and it will just blindly do its task. And that's why it has only one force. Same here. The ground allows this point to move sideways. Yeah, the cable may prevent it, but the ground doesn't. The ground also allows it to rotate around like this. Yeah, the other bars may prevent, but the ground doesn't. Excellent. What I want you to do is look at this figure and draw for me the free body diagram of ACE. The way I want you to do it is pause this video, draw it yourself, and then come and look at what I have. Did you pause the video? Did you draw it by yourself? Yeah, very good. So I will show you. This one is going to look like this. This is A, C, E. So at point A, again I have FA ground and I have FA cable, and then now I have to decide what I'm going to do here. Newton's third law will tell me that this has to be equal and opposite. FCY, FCX. This forms an equal and opposite pair. We'll talk about Newton's third law in a little bit more detail when we get there. But right now I just wanted to show you. And then there is the F drum here. Did you see how this is kind of a mirror image, except for this? This force and this force have to sum to 0. When I put them together, the force vanishes. Okay, this is kind of hard, so stare at it a little bit. Okay, we will come back to these kinds of free body diagrams. I'm just introducing you to the idea. Okay, very good. Now I'm going to go to the next one. This is an actual figure. So this is a trash bin, and I want to be able to draw the free body diagram for it. So my judgment is I'm going to draw side view. Right? In side view, the drum looks like this. Can you see that? Right? And it's resting on this ledge here. And it's a pin joint A. Now let's draw the free body diagram for this. Okay, so I'm going to draw the drum. The center of mass of the drum is somewhere there. That's usually referred to as G. This is the point A and this is the point P. What do you think is happening at A? Pin joint at A. Is that obvious to you? Because here it allows this hinge allows you to rotate it freely like that, but it does not allow either this way, this is not allowed, this is not allowed. Right? So it's a pin joint. So I'm going to put FAY, FAX. What about at point B? It looks as if there's something that's a blunt thing contacting a surface. That's what this point looks like. Right? If it's a blunt thing going on a surface, it's like a rocker joint. It's this guy. What it means is that there will be a force that pushes that way. So we're going to draw that force. F bar. This is hard. You're beginning to get that now. You know, you have to actually make decisions about what is happening in all these things. Okay, and you have to understand that a rocker bar, which is like this, you can see that now, it looks like that. It allows this motion, so no torque. It allows this motion, so no tangential force, but it does not allow this motion. So there is a force that way. That makes sense to you? So let's get back. So here is my drum. That's the drum, or let's see. Yeah, here it is. That's the drum. It allows this motion for the drum. It allows this motion for the drum. But it does not allow the drum to go through. That's why there is only that force which prevents the drum from going through. Very good. Let's look at the next.